Hello students. In the last class I told you about the two types of adsorption, that is a physical adsorption and chemical adsorption. We already discussed the different characteristics. Today let me continue in this class about the differences between physical and chemical adsorptions. Okay, so to begin with the first point, what is physisorption? Can you remember the definition? It is a type of adsorption in which adsorbate and adsorbent, the two components, are held together by van der Waals forces, whereas in case of chemisorption, the adsorbate and adsorbent are held together by strong chemical bonds. Okay, so definition you understood, that you can write as one of the differences. Now coming to the second point, just now I told you as a part of definition, what is the bond present between them? In case of physisorption, there is a weak van der Waals forces, whereas in case of chemical adsorption or chemisorption, it is a chemical bond formation. Okay, so because of the strength of the bond, we can understand about the specificity and also reversibility in the next points. So I hope you understood the second point. In case of physisorption, there is a van der Waals bond formation. In case of chemisorption, there is a chemical bond formation. Okay, moving on to the point number 3. Which is specific among these two? Usually asked for a 1 mark question among physical and chemical adsorption, which is highly specific. You must remember, chemisorption is highly specific, whereas the physisorption is not specific or non-specific. Okay. Now, moving to the fourth point, I told you just now, since the bond present in case of physisorption is a weak van der Waals forces, we can detach the accumulated molecules. So this process becomes reversible. Physisorption is a reversible process, whereas chemisorption is irreversible process. That is a fourth point. Coming to the fifth one, even though there is a bond formation, the strength of bond is different. Because of that, the amount of heat liberated during adsorption also varies. In case of physisorption, the enthalpy of adsorption is low and it is in the range of 20 to 40 kilojoules per mole, whereas in case of chemisorption, amount of heat liberated or enthalpy of adsorption, what do you say? It is high, it is in the range of 80 to 240 kilojoules per mole. So just remember students, the range of the heat liberated during physisorption and chemisorption. Okay, that was the fifth point, amount of heat liberated or enthalpy of adsorption. Moving to the sixth point, what is the effect of temperature on physisorption and chemisorption? In case of physical adsorption, it is usually favored at low temperature. I told you, the easily liquefiable gases can be absorbed easily. So, physical adsorption is favored at low temperature, whereas chemical adsorption is favored at a high temperature. Okay, so this is a sixth difference. I hope you understood the first 6 points, differences between physical and chemical adsorptions. Are you clear? Any doubt till here, till the 6th point? Before I move on to the 7th point, remember I told you the first point definition, the type of bond, specificity, reversibility, enthalpy of adsorption, and what is the effect of temperature. Okay, so now let me move on to the next difference between the physical and chemical adsorption, about activation energy. Generally, in case of chemisorption, to form the strong chemical bond, it needs a higher activation energy, whereas in case of physisorption, since a bond is a weak van der Waals forces, higher activation energy is not required. Okay, so remember the 7th point, in case of physisorption, no appreciable activation energy is needed, means it will happen at low activation energy also, whereas in case of chemisorption, it requires high activation energy. You already studied in other chapter what is activation energy and other details. I will not go to the details of what is activation energy here. Okay, so that is a 7th difference. Moving on to the 8th difference, what is the number of layers formed? In case of physical and chemical adsorption, I told you in the previous class, generally in case of physical adsorption, since the weak van der Waals forces are there are many layers accumulated. So we can say it is a multi-molecular layer. So physisorption results in multi-molecular layer, whereas chemisorption results in a unimolecular layer. There is only one layer of molecules adsorbed on the surface of adsorbent in case of chemisorption, whereas in case of physisorption, many layers are accumulated. It is not restricted to single layer of accumulation. Okay, so that was the 8th difference. Moving to the 9th one, which type of gases adsorb easily? Even though we understood the physical adsorption is non-specific and chemisorption is a specific, and we usually say both these type of adsorptions depends on the nature of gases which is accumulating, still we can understand the difference here. In case of viscosoption, easily liquefiable gases, I told you about a critical temperature also. Easily liquefiable gases are adsorbed easily in case of viscosoption, whereas in case of chemisoption, we know there should be strong chemical bond. So gases which can react with the adsorbent, means it forms a chemical bond, it can show the chemisoption. So any gas we can't expect a chemisoption, or any gas undergoing a viscosoption is not possible. The nature of the gas is a factor deciding viscosoption and chemisoption. Okay, so that was the 9th difference. Moving on to the last point here, the 10th difference. We can list out so many differences, but you remember 10 differences at least. What is the last point here? What is the effect of pressure? I told you when I mentioned about the characteristics of adsorptions in the last class. Usually, in case of viscosoption, if you increase the pressure, rate of adsorption also increases. Okay, if you increase the pressure, more and more number of layers getting adsorbed in case of viscosoptions only. Whereas in case of chemisoption, what happens? When there is a surface area available, if you increase the pressure, there may be adsorption. But remember students, once the one layer is adsorbed, after formation of a unimolecular layer, whatever be the high pressure you provide, it is not possible to accumulate the second layer on the adsorbent. So I can say pressure has no effect after accumulation of one layer of the molecules. Okay, so this is about the differences between viscosoption and chemisoption. Usually asked a question, sometimes it will be asked for 4 marks also. You have to write 4 differences between viscosoption and chemisoption. Okay, any of the points you can select. Okay, easier points also there. Nature of the adsorbate, you have to remember. Reversibility, enthalpy, whichever the point you can remember, but specify. Don't write the same point in a different meaning 2-3 times, because we have so many differences between viscosoption and chemisoption. Okay, after completing this physical and chemical adsorption differences, now let me move on to the one more interesting factor here about the application of adsorption. Okay, so you know what is adsorption, what are the types of adsorption, and other details we understood till now. Now let us move on to what is the use of this adsorption, where and all it is applicable. So application of adsorption, again many points we can list out. For your syllabus, let me tell you just 10 points. What all the applications of adsorption? Let me move on one by one. The first one, production of high vacuum. Suppose within a container, if you want to create a vacuum, if you want to remove the gases present there, we use usually activated charcoal. Now what happens here? Within the container, if a charcoal is there, it will adsorb the gases, so it will help to create the vacuum. So this is the first point, application of adsorption, production of high vacuum. Now second point, especially you have seen maybe the gas mask used by the workers working in the coal mines. There are so many poisonous gases released, and that poisonous gases is to be absorbed. Again, they are using the charcoal there. On the surface of the charcoal, these poisonous gases getting absorbed. So the gas mask used by the workers in the coal mines, that is also working on the principle of adsorption, where charcoal is there, the poisonous gases getting accumulated on the surface of charcoal. Okay, now the third one, control of humidity. You may be seen in the small tablet bottles, the small packets of silica gels. Now why the silica gels are kept? They are absorbing the moisture. So control of humidity is also done. It is also based on the principle of adsorption. Okay, that is the third application, control of humidity. Moving to the fourth one, removal of coloring matter from the solution. I told you when I started with the adsorption, the decolorization of sugar. The sugar cane juice, what is the color and what is the color of the sugar? If you compare the difference, you will understand. The decolorization was done using animal charcoal in case of decolorization of sugar, and similarly any other colored solutions can be decolorized by adding some adsorbent. It is not required always charcoal only. There are many more adsorbents on the surface of which the coloring matter can be adsorbed, making the solution colorless. Okay, now that was a removal of coloring matter from the solutions. Coming to the fifth one, heterogeneous catalysis. You may not be knowing what is catalysis now, which I will explain in the next class, but try to understand Heterogeneous catalysis, many more examples are there. Anyhow, if I discuss now, you will not understand. I will discuss about catalysis, the different types of catalysis, then I'll mention about it. But the simplest example, after understanding P block elements, you know, synthesis of sulfuric acid by contact process, where sulfur dioxide is oxidized to sulfur trioxide in the presence of platinum or vanadium pentoxide, which is one of the examples for heterogeneous catalysis. Okay, so we use a catalyst there. The reacting molecules are gases. Catalyst is a solid and the gases accumulates on the surface of solid. It is an example for heterogeneous catalysis. Many industrial process which works on the heterogeneous catalysis is also an application for adsorption. Okay, now one more interesting thing, inert gases, we know the noble gases, helium, neon, argon, krypton, xenon, radon. Among these, radon is not present in the atmospheric air, but except that, rest all present in the atmospheric air. If you are purifying them, if you want to separate these inert gases, then also we use the same charcoal. The process of separation, isolation and separation of the inert gases which are chemically less reactive, it is done based on adsorptions only. So that is a one more application for adsorption, separation of inert gases. Okay. The seventh point, the next application of adsorption, if you want to study, many diseases, most of the drugs, they are also in a colloidal form. In the same chapter, I will discuss about what are colloids, and there the curing of diseases using some medicine which is based on the principle of adsorption, okay, which is almost a biochemical level, but you can understand some of the drugs or some of the medicines which works on the principle of adsorption, that is used in the curing of diseases. Okay, now when you study about a metallurgy, separation of various components and purification comes, there comes one of the process called as a ore concentration by froth flotation. When you discuss about the general principles and processes of isolation of elements, you will become clear with that. Sulfide ores can be concentrated by froth flotation, which is based on the principle of adsorption only. So this particular froth flotation process you will discuss in detail in metallurgy chapter. Okay, that is also working on the principle of adsorption. Coming to the ninth point, adsorption indicators. Again, the different precipitate form and the precipitate can be separated, which can be indicated using some substance, that also on the principle of adsorption. And the last application of adsorption is chromatographic analysis. You know, chromatography you heard in the first year syllabus. One of the method of separation of the components, one of the method of purification in a mixture which works on the principle of adsorption only. There may be a stationary phase, mobile phase. On the stationary phase, the mobile phase is moving, they getting detached later on, but they get adsorbed on the rate of density. Okay, and that is also working on the principle of adsorption. So it can be asked for a 2 marks, write any 2 applications of adsorption. Instead of writing any points, you can just remember some of the key points here. Production of high vacuum, the gas max, control of humidity, removal of coloring matter from solution, heterogeneous catalysis, separation of inert gases, curing of diseases, froth flotation process, adsorption indicators, and chromatographic analysis. So these are the some of the applications of adsorption. Okay, so in this class we studied about the differences between physical and chemical adsorptions and applications of adsorption. In the next class I will continue with the catalysis and the types of catalysis in detail. When I told you about the applications of adsorption, I mentioned about a heterogeneous catalysis. Then I told you, I will tell you what is catalysis and what is heterogeneous catalysis. Let me tell you something about catalysis today. Okay, let me look at the simple equation. Nitrogen reacts with the hydrogen to give ammonia. You heard about this process. You studied this process in the P block elements. It is a reversible process. And you can balance the equation as 1 mole of nitrogen and 3 moles of hydrogen forming 2 moles of ammonia. Okay, what is the name of the process? It is called Haber's process. Now, this reaction happens without the catalyst also. Okay, but if you add a catalyst like iron, then the reaction becomes faster. Okay, so now the question you ask, what is the role of iron? Iron acts as a catalyst. Okay, now the basic question you ask, what is catalyst? Before we understand what is catalysis, you should understand what is catalyst. In this Haber's process for the synthesis of ammonia, iron acts as a catalyst. So the role of iron is to make the reaction faster. Okay, I can say this is acting as a positive catalyst. Before we understand what is positive catalyst, what is negative catalyst, try to understand what is catalyst. Simple. Catalyst is a chemical substance which alters the rate of reaction. Remember students, I used the word which alters. It may not be only increasing, it may decrease the rate of reaction also. Okay. Catalyst is a chemical substance which alters the rate of a chemical reaction. You know what is rate? Chemical kinetics, when you studied, you understood about it. The speed of reaction is affected by adding some chemical substance. So, iron acts as a catalyst in this case. Remember the definition? Catalyst is a chemical substance which alters the rate of chemical reaction without undergoing any chemical change. The catalyst will remain same at the end of the reaction also. When you list out the different characteristics of catalyst, you will understand that it remains same at the end of the reaction. It will just monitor the rate of the reaction. It won't be consumed during the reaction. Okay, so you understood what is catalyst, right? Substance which alters the rate of chemical reaction without undergoing any chemical change. Now, the previously when I wrote just the reaction without iron, then it is called reaction. But when I added iron here, it is called as a catalysis. Okay, now you understood what is the difference between a reaction and a catalysis. Correct? No? If there is no catalyst, then it is just referred as a reaction. When you add the catalyst, it may be any of the catalysts, positive or negative, then that process is called catalysis. So catalysis is also reaction where catalyst is used. Okay, so we understood what is catalysis, we understood what is catalyst. Now, let me move on to different types of catalyst. Okay, just like I told you now, the substance it may increase or decrease the rate of reaction. I mentioned, you are remembering, there are two types of catalysts. One is positive catalyst. Can you guess what is the second type of catalyst? The positive catalyst is a catalyst which increases the rate of reaction, and the negative catalyst is the one which decreases the rate of reaction. If you study about food preservatives, those are the chemical substance which decreases growth of microorganisms. They act as a negative catalyst. Okay, so you understood what is catalyst, what are the two types of catalyst. Okay, now let me move back to the types of catalysis. The catalysis also of two types. Okay, what are the two types of catalysis? Again, before I tell you the types, I'll give you two examples and you have to distinguish between them, then you come back to the definition. Okay, I will write one equation. Potassium chloride AClO3, you studied this in the preparation of dioxygen in the p-block elements. On heating, it undergoes decomposition to give potassium chloride and oxygen. You studied now, this reaction you studied in the p-block elements. To balance the equation, you write 2 KClO3 forming 2 KCl and 3 O2. Actually, this reaction is very slow. It takes hours together for the completion. And the same reaction can be made faster. We can finish it in few minutes by adding a chemical substance like MnO2, manganese dioxide. Okay. Now, before I write MnO2 there, it was just a reaction. When I write MnO2, the catalyst in the reaction, it becomes a catalysis. I told you, catalysis is a process where catalyst is used. This is one of the examples for catalysis. I will take up another example like sulfur dioxide undergoes oxidation to give sulfur trioxide. You know, well-known contact process in the manufacture of sulfuric acid. 2SO2 converts into 2SO3. I told you just now, it is just a reaction. When I write something about the arrow mark, when I write the catalyst there, it becomes a catalysis. So, I will write platinum. It can be vanadium pentoxide also. Now, these are the two examples in front of us. Both are catalysis. But there is a major difference between these two if you study. I am not telling about the process or industrial process here, but I am just mentioning one is an example for homogeneous catalysis. Students, you are understanding? There are two types of catalysis I am mentioning now. The first one is homogeneous. Can you guess what is the second one? You are genius. Homo means the same. The next one is heterogeneous. Homogeneous and heterogeneous catalysis. The two types of catalysis usually ask for 2 marks. Definition and an example. What is homogeneous catalysis? Give an example. Or explain heterogeneous catalysis with an example. When it is asked for 2 marks, you write a definition which carries 1 mark and example with the catalyst. Don't just write a reaction, because I told you catalysis includes the catalyst also. Okay, now how can we distinguish between these two? The potassium chloride decomposition into potassium chloride and oxygen, sulfur dioxide undergoing oxidation to give sulfur dioxide. Among these two, if we compare, what is the major difference we can understand? Let me write the physical states. Potassium chloride is a solid. Manganese dioxide is also solid. Okay, you may ask the question, why I am not writing the physical states of the products? It is not required for me. When I want to compare homogeneous and heterogeneous, we are least bothered about the physical states of the products. We are concerned only with the physical states of the reactants and the catalyst. Okay, so what is the specialty you can observe in this particular reaction? Can you tell me, students? See, reactant is potassium chloride. It is in the solid state. Manganese dioxide, what I added as a catalyst to increase the rate of reaction, it is also in the solid form. So, if the reactants and the catalysts are in the same phase, PHAC, if they are in the same phase or same physical state, then this example is an example for homogeneous catalysis. Okay, so can you tell me what is homogeneous catalysis then? What is the definition of homogeneous catalysis? It is a type of catalysis in which the reactants and the catalyst are in the same phase. I repeat, homogeneous catalysis is a type of catalysis in which reactants and the catalyst are in the same phase or same physical state. Okay. Again, I told you, in case of products, whatever in the physical state, it may be solid, liquid, gas, we are not concerned with that. Only we are comparing with the physical state of reactant and the catalyst. Okay. Moving on to the second example. See the difference here. Let me write the physical states of the reactants and the catalyst again. Sulfur dioxide, what is the physical state? It's a gas. Oxygen, it is also gas. Platinum, being a metal, its physical state is solid. So, when you compare the physical states of the reactants and the catalyst, what you can see in this case of contact process is reactants are gases, whereas catalyst is a solid. The reactants and the catalyst are in the different phases. They are in the different physical states. So, this becomes an example for heterogeneous catalysis. So, now come back to the definition. What is heterogeneous catalysis? It is a type of catalysis in which the reactants and the catalysts are in the different phases or they are in the different physical states. Okay, so so many industrial processes, so many examples you studied, you can easily list out which is homogeneous and which is heterogeneous based on that. But basically, first remember the definitions and at least one example. Okay, homogeneous catalysis is a catalysis in which reactants and catalysts are in the same phase. Heterogeneous catalysis is a type of catalysis where reactants and the catalysts are in the different physical states or in the different phases. Okay, so this is a simple types of catalysis, and most of the adsorption phenomena we study with respect to heterogeneous catalysis. Okay, in case of heterogeneous catalysis, what happens? We usually consider the solid as adsorbent and gases as a adsorbate, the molecules which are getting accumulated. Okay, so this is easy about the two types of catalysis, homogeneous and heterogeneous. Are you clear? So in this class, what we studied, what is catalysis, we understood, a process where a catalyst is used, and then we understood what is catalyst, chemical substance which alters the rate of chemical reaction without undergoing any chemical change. There are two types of catalyst, positive catalyst and negative catalyst. Positive catalyst increases the rate of reaction, negative catalyst decreases the rate of reaction. Then we studied about the types of catalysis. There are two types, homogeneous and heterogeneous. I told you one example each. Okay, at the same time you can understand many more examples for a catalysis and you can easily compare, is it an example for homogeneous or heterogeneous catalysis. Okay, based on this heterogeneous catalysis only, we will understand in the next class about adsorption theory and mechanism of catalysis. Okay, mechanism of catalysis can be understood with the example of heterogeneous catalysis, which I will take up in the next class. Okay, I think you understood about catalysis here. Okay, thank you.